Okay, so now you had a chance to draw these graphs. The reason that I want you to draw these graphs for once is just to get to know that tan graph better, but it also helps you, especially in science, okay? So we drew the graph for tan from 0 to 360, okay? This is the curve for tan theta. Now we noticed something a bit weird. At 90 and at 270, there was an error message. Okay. Now I want to find out what does it mean. That in fact what the calculate tells you is that it's undefined. Tan 90, oh, tan 90 is undefined. Okay. Why is that? Always, you notice, I always go back to that circle. This is such an important circle for trig. So if you remember, I've got this dot that moving around the circle, okay? The angle theta is here. Tan theta will be equal to what? If this is the x coordinate, if this is the y coordinate, yeah?
Y over x.
Y over x. Okay? Now let's try see what happens to tan as we go around from 0 to 360. When my dot is here, okay, what is y equal to? What's the y coordinate here?
0.
It's 0. Okay, it's purely x. There's 0 y coordinate. So if y is 0, what will be tan 0? 0. Okay, and in fact you did get 0. Now as my dots move over to here in this direction, what happens to y? Is it getting bigger or getting smaller?
Bigger.
It's getting bigger. So when my y gets bigger, my x actually get a bit smaller, so the tan theta gets bigger, and it is getting bigger, 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 bigger. Okay? Now, by the way, there will be a specific angle where that angle is 1. What happens when tan theta is equal 1? What do you reckon? What does it tell you about y and x? Here.
Then you have to divide it by 0 because x is 0. And you can't
No. You're jumping over. Not exactly. So tan theta is equal 1. Okay, let's say. I want to find out where does it cross the 1. Which angle tan theta gives you 1? It's actually a special angle. It's not 60. We've learned that.
45.
It's 45. Why is it 45? What happened at 45? What can you tell me about y and x? Okay, if this is 45, what can you tell me about y and x? Cameron said it's half 90, I think, okay? That means this is also 45. So what can you tell me about y and x, guys? They're equal. They're equal. Can you see? If this angle is equal to that angle, then y and x are equal. And if y and x are equal, what will be then? So tan 45 is y over x. We say y and x are equal. So what is it equal? 1. Okay? So just by thinking, without actually measuring, we know when tan theta is 1. It's going to be for 45. Okay? When the angle is 45, the tan theta is 1. Let's move on. I'm increasing the angle, okay? Back into theta, okay? I'm increasing the angle. The y carries on getting bigger, 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 bigger here, okay? What happens to x all that time? As I move around, what happens to x? It gets smaller. So when I get to tan 90, what is x equal to? 0. And what happens when you divide by 0? It's undefined. It actually goes up to infinity. I think I might have chatted to you about that earlier in the year. Okay? When I divide by 0, it blows up to infinity. So why did I ask you not to connect all the dots? Because as I'm going closer and closer to 90, this graph goes up like that. It blows up to infinity. Okay? So the way we draw it, we draw this arrow. We must draw an arrow to show that it carries on up. This vertical line is called an asymptote. Asymptote. And we're going to learn about these things also in our next topic, functions. So we're getting already used to it. It's actually a vertical asymptote. Okay? The graph never crosses. Okay? If you have a certain line that the graph never crosses, get closer to it. Get closer, closer, but never really reach it. It's called an asymptote. The same thing, and I'm not going to get into detail why, but you can probably think about it yourself if you really want to at home. Okay? This line on the other side of 90 goes down, dives down, closer and closer to minus infinity. Okay? And the same thing happens at 270. Again, you can think through it. Just the same thing that I've done here, you can try in a third quarter. The same thing will happen. As I get to 270, the tan gets bigger and bigger and bigger. It approaches infinity. And on the other side, it approaches minus infinity. Okay? So that's the tan graph. Tan graph, grade 10, tan graph. Okay? It's a little bit different, isn't it? It's a little bit different to the sine, cosine. It's not like up and down. It's not continuous. You will learn that one day maybe. Okay? All right, last thing I want to say. No, there's a couple of things I want to say. No, let's just say one. What is the periods? And Junaid was up to it straight away. And I think Luano to some extent is very close. What is the period? Remember, what does period mean? Period is the amount of angle before it starts repeating itself. Okay, so far we only looked at 360. All our periods function will have 360. You had to have 360 degrees to copy and paste, make the new pattern. What will it be here, Liam?
From 90 to 270.
So you can say from 90 to 270. Okay, see if I take this little line from 90 to 270, it's going to look like this. If I copy and paste, okay, I'm reproducing the angles, you're right. But from 90 to 270, how much angle is it? How much is it from 90 to 270? It's 180. So the period is 180 degrees. Okay, Leo decided to start 90 and end to 270. That's 180 degrees. But I could have started from 0 and end at 180. Look at this. If I decide, I can take it like this, like that. Okay, that's this picture. And then reproduce it again. I'll do it in a different color. So like this, like that. Okay? And then I can reproduce it again. Like this, like that. Am I getting back the same graph? I'm getting the same graph. So whatever it is, wherever you start, you always need another 180 degrees to have the full picture of that graph. That's the period. Okay, I'll pause here, let me give you a chance to ask questions, and then we take it from there. So we spoke about the period. We didn't talk about minimum, maximum, and range. Okay? Maximum, remember, is the maximum value of the tan. Do we have a maximum value? No, it just gets bigger and bigger and bigger to infinity. So there's no maximum. What about minimum?
No.
Also no, it goes down, dives down to minus infinity.
No, I don't even find this. Yes.
Interesting. Somebody just carried on. Tan.
How did they even think about tan?
Tan 89.9. Tan 80. Okay, now what is the range? Now here, I've got a funny feeling. I actually said something wrong a couple lessons ago. When we're looking for, I'm not sure. When we're looking for the range, we're looking for the values of the y, not the values of the x. And I think I might have told you last lesson is the value of the x between 0 to 360. And if I did, that was wrong. We need to look at the values of the y. Okay? So what are the values? This is exactly what Hinkel was just telling me a little while ago. Okay? Well, I shouldn't really do that. What are the values of the y? We said there's no maximum, no minimums. So what values are we going to have? From minus infinity to plus infinity. And then Hinkel, what did you tell me?
Round bracket.
It's going to be round brackets because we obviously never really reach them. Okay? So that's the range for the tan graph. That's the range for the tan graph. Okay? That's the range for tan. Now, Ma'am is shaking her head here, so I think I did make that mistake when we spoke about sine and cosine. So let's just quickly write down the range. Okay? Let's talk about the range for sine and for cosine. Okay? And that could be a little quick revision for you, and you can correct what we wrote in the book. Okay? What will be the range for sine theta? Okay, remember range is the y values. Yes.
1 and minus 1.
Correct. But we always start from the smallest one. So from -1 to 1. Now, is this right what actually I've done? I've done something wrong.
You need a square bracket.
I need a square bracket because it is including -1, 1. You're right. Okay, that's the range for sine, cosine. What about cosine?
It's gonna be the same.
It's going to be the same. It's going to be the same. We're still going from -1 to 1. Okay? So that's the range for sine and cosine. That's the range for tan. How should I write? The range of tan. Okay? They are different. Okay. Right. Now I'll pause, clear out, and we'll mess around with this graph a bit. Is it done?